Hi all, welcome back to the Crazy Small CPU video series. In this latest video I've got the address lines wired up, those yellow lines. And what I've got is the program counter values going up into the two ROMs, and I've been able to test and check that the address ROM is producing the right RAM addresses to access particular locations in RAM. But before we get to testing it, I just want to show you how difficult it was to get the wiring set up. So if we start with the schematic of the Crazy Small CPU, over on the bottom left we've got our two chips that make up our program counter, and the output of the program counter, lower 4 bits and upper 4 bits, go up and some of the address lines for the two ROMs. The control ROM used to be called the top ROM, and the address ROM, which used to be called the bottom ROM. And the output of these feed over, or at least the output of the address ROM feeds over and forms the address for the RAM. And also remember, the low 4 bits form the constant we feed into the multiplexer. However, those 8 bits from the program counter are not the only bits that come in as address lines to these ROMs. In fact, we also take the NZVC output of the flags register, and we use those as 4 address lines. So they also have to be brought over and fed in on 8, 9, 10 and 11 for both the address ROM, and also fed down to feed in the same place for the control ROM. So we've got address lines coming up from the program counter, and we've got address lines coming over from the flags register. Now, I just showed you that the output of the address ROM is going to be an address to apply up to the RAM chip, and also the multiplexer. But it gets even more complicated than that, because when we want to jump to a certain location, then those 8 bits of the address output from the address ROM also have to go down and become the inputs to load into the program counter, so it can jump to a specific absolute location. So overall, this corner of the breadboard is going to get awfully messy. So I took some photographs as I was actually doing up the wiring, just to show you what sort of wiring density this is actually on the board. Alright, so down at the program counter end of things, we've got 4 bits coming out, low bits, and 4 high bits coming up and going into... Oh, I've also pulled out the socket, the ZIF socket. In fact, I've actually got a ZIF socket mounted in an IC socket. That gives me much more spacing, and you'll see the reason why I need spacing. I certainly need to have spacing because the ZIF socket itself actually sort of takes up most of the breadboard. So I need to raise that up vertically to be able to get some of the wires in underneath. If you look at it sort of side on, you can actually see I've had to lift wires up vertically so that they will run over the top of other wires. And of course these 8 bits have to come into the control ROM, but then they've also got to come back out again, so I've got to have an extra set of address wires raised up to clear those, so I can take them up to the bottom ROM, which is sending out the address over to the RAM. Okay, so you can see vertically I've had to raise them up substantially, and that's why I needed to have first of all the socket to go into the board, and then the ZIF socket on top of that, and then of course the ROM sit in the ZIF socket. Here are the 4 address lines coming in from the output of the flags, and they come in and get wired up as the top 4 address lines on this ROM, and also we have to carry them over so that they get wired up in the same place on the control ROM. So here's a more vertical picture of those 4 wires coming in from the flags over into the address ROM, and then over down to the control ROM. You'll notice that the output of the address ROM, 8 bits, gets wired over to the RAM, but unfortunately 3 of those bits actually live over on the left hand side. So I think it's IO0, IO1 and IO2. So I've actually wired them down to these 3 places down here, and this is before I put the jumper in, the 3 jumpers, so that I can actually get at them over here And it actually turns out quite nice because that now becomes IO0, IO1, IO2, 3, 4, 5, 6 and 7. So we've got a nice set of diagonal wires going over into the RAM to provide the 8 bits of addressing. You'll notice that I forgot to put the chip enable lines and the output enable lines in before I did my address wiring. So I've got these lovely little loops, which are sort of actually nice. They physically hold down the cabling, but I really should have put those in first. So you really have to plan ahead when you're doing this density of wiring. Just another view from the side, just to show you how much vertical clearance I've had to bring up in order to get the wires to sit happily on one on top of each other, and the same thing on the other side. You'll also notice that I actually penned in the outline of where the socket is going to go on the breadboard, so that I could pull out the socket, solder it onto the zip socket, still know where things are going, and then I can put them back in. And fortunately there's enough clearance. I mean, I think this is about 3.5, maybe 4 mils vertical metric mils clearance, and I've still got enough room to put the sockets in. Okay, so let's look at how I'm going to test this. Unfortunately now I've got the program counter working, and the program counter is feeding addresses, program counter values up into the address ROM. So what I can check is the address ROM getting the right value from the program counter, and I can also check whether the address ROM is feeding the right address out over to the RAM chip. So I've got a test program which basically for program counter value 0 will put the number 1 on the address bus out to the RAM chip, and then the number 2, the number 4, the number 8. So I'm actually lighting up one bit at a time to prove that each and every bit line is working. Then I've got an all bits on test to make sure that all 8 bits are on going to the RAM chip. Top 4 nibble goes on and the bottom 4 nibble goes on. And if I actually assemble this and turning on debugging, you can actually see that 01, 02, 04, 08 are the values that are going to go down into the address ROM, and the actual instruction itself, E8, 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 is all going to go into the controlled ROM. And right down at the bottom, I've just put this in so that if I ever simulate it, it'll actually stop. So the jump will jump back to itself at 0B. So I should also expect to see 0B as the last valid ROM value in the address ROM. So I actually now show you botrom.image. If I actually show you what's in the binary that will get written over to the ROM, which I have already actually done, you'll see 1, 2, 4, 8, 10, 20, 40, 80, FF, F0, 0F, 0B as the first 16 values in the first 16 locations in the ROM. So as we put the program counter in, each and every one of those should come back out and be sent over to the RAM chip. So let's go and try that out. Back over to the breadboard, I've got the memory reset line wired high, but I'll lower it in just a minute. I've got the PC increment line wired high so that the PC is going to actually count. I've got the low 4 bits of the program counter, the high 4 bits of the program counter, and I've got the low 4 bits of the address coming out of the address ROM and the high 4 bits coming out of the address ROM. Now remember, what we're expecting to see is 1, 2, 4, 8, 10, 20, 40, 80, and then an all-on test, and then one nibble turned on, the other one off, and then one nibble turned on and the other one off. And then I think B was the last number we should actually see, hex B. So let's reset the program counter. Alright, so we're still running, you probably can't see this because of the lights, so we're on location 0. 8 bits of zeros are going up to the address ROM, and we're getting the number 1 out of the ROM, which is excellent. So moving up to the next location. Location 1, we've got the next bit coming out, then the next bit coming out, the next bit coming out. We're up to location 3, program counter 3 I should say, program counter 4. We've got the next value coming out on the address, 5, and it seems to be working. We're getting up to the high bit turned on, so hopefully in the next one will be all on. And we've got all 8 bits on over there. Then we should have a nibble test. So the top nibble stays on, the bottom one goes off. And the bottom nibble goes on, top nibble goes off. And I think B was the last number. That was the jump that we're not actually using except for the simulator. Anyway, it does look like the address ROM is working. It's getting its program counter values, sending out the 8 bits over to the RAM chip. So that's excellent. And that probably also means that I could probably have wired up the control line to get the PC to jump to itself. In the next video, we'll have a look at the control ROM. I already know that there's a bit of a solder issue with one of the pins on the control ROM underneath, and I'll have to fix that up before I do the video for the next one. Okay, that's it, and I'll see you on the next video.